4.4 in Geometry Revisit. Reflections. Okay. And I guess the chapter 4 is about transformations. So actually we're viewing geometry stuff in terms of functions. Okay. So you know what a reflection is, right? So there's a line that fixes stuff. So here in the diagram they have is HK along this line. It's called the mirror. You basically take a point A and you reflect it to the point on the other side, yeah? Alright, so remember, reflections are what's called an isometry, which means they preserve distance, okay? And so we did an exercise before. If you preserve distance, it has to be 1 to 1. You know that? Yeah. Okay, so and then it's clear that this has like order 2, so like it's its own inverse. It's not only 1 to 1, but it's also onto. So as a function from R cross R, R cross R, and it's self-inverse, yeah? Another way of saying that is it's an involution. Okay, so let's see what the book has to say, okay? Okay, so at each point is the A. So A prime is bisected, yeah? And if you have a B here, B prime. So is it obvious that if you take C and you make C prime, it stays on the line? It's on the reflected line. Yeah, I guess it's all obvious intuitively. So I guess that would make it affine. Preserves collinearity, yeah? Would you be able to prove it explicitly? Yeah.
Because the distance, like the difference between, like if you prove that AC prime and AB prime have the same gradient.
Mm-hmm.
Yeah, so
like you can do that using distance.
Or I can use similar. That's harder.
Mm-hmm. So yeah, so you have this distance is equal, that distance is equal, right? And then obviously the horizontal distance equal, yeah? So then the slope
Is equal.
is like equal, negative or something, yeah? But that's between A and B prime, yeah?
And then you can do the same for A and C.
Yeah. So then
They have the same gradient and they have, and so they're collinear.
yeah, so then the slope between A and C is the negative of the slope between A prime and C prime. Oh, come on, you press the button. Yeah, so I guess it suffices to show that the slope A prime C prime equals the slope A prime B prime, yeah? And then we know that this A prime AC
And what the gradient of the
has negative slope to that, and it has equal slope to AB, right? So then A prime C prime
Must not.
has the same slope as A prime C B prime. Yeah? Okay, so that's what affine is. It means it preserves collinearity. Okay. The trapezoid A prime, B prime, B has diagonals AB prime and A prime B, which are images of each other. Yes, I mean, I do encourage you to read the book as well on your own. And one day I'll be like trying to tell you from the book, and you're like, no, I've read that page. Let's do another page. Okay, so and obviously the points on the mirror are fixed. Yes.
Yes.
The common point is X, and it lies on the mirror. Is that obvious? Diagonals are images of each other. So that's meant to be the reflection of that. Is that obvious? And is it obvious they intersected X?
Well,
Yeah, because
so it's the equidistant.
Hmm?
Like if you draw it out and assume it's log x,
Yeah.
then they would both be like equidistant from
why?
like A and A prime.
Yeah, if like X was like closer to AB than H, than A prime to D prime, then that means like B to HK is not equal to B prime to HK.
Yeah, so I guess it's kind of weird trying to show things that you already think is true and obvious.
Yeah.
But it does give you an exercise in the reasoning, especially explicit reasoning that we kind of lack sometimes. So maybe it's more obvious to say that this is the reflection of this, or that's the reflection of that. So what did you say?
Like fruit A HX and A prime HX are congruent.
Oh, yeah. Exactly. Oh, come on.
It was open. Yeah, it is open. Oh, sorry.
Okay, we'll do the sequences. Oh, yeah, bring up.
Yes.
Give him a seat. Come on.
I managed to solve the sequences.
Oh, great. All right, we'll go through next. Okay.
Okay. So I write it out, just practice a bit of
Yeah. Go for it. Well, we're doing this. Oh, you know, Jaru.
Oh, yeah.
Okay, cool.
What?
So
General.
yeah, so these triangles are SAS congruent. Yeah.
Yeah.
So then,
So which question is this?
this is the reflections chapter.
Oh, it's the chapter 4. You skipped that last time.
So this is the same angle, right? And so that makes that a reflection.
Isn't that
This
it's
is the
defined?
same.
It's by definition.
Yes, sort of. Yeah. Well, I guess if the angles are the same, any line you draw in here perpendicular will be bisected as well.
Reflection is so you can reflect any shape, a line, a point, across any line.
Yeah.
Can you reflect anything about a 2D object?
Huh?
Like, can you do a reflection about a 2D object? Just curious, because like, you can do complex numbers, which are which you extend a 1D concept into 2D.
I really think rectangle.
Oh, that's kind of interesting.
Can you like reflect a 3D present number like a plane? Like, yeah.
But you could, yeah.
Yeah.
Because like, if this paper is really thin, and in a pen,
Yeah, as long as there's sort of like a notion of perpendicular, you can reflect it. Okay, so what's the point of this? Oh, actually, did we even we actually made an assumption that x was the point of intersection.
No, actually, don't assume, and then they both. Like if you don't assume that, then
Oh, we
the
kind of
reflectors
then
are
Yeah, we
equal.
did
Like,
kinda-
x is the
we kinda
distance
did
of
assume
x from like A, and this is from x to like A prime, then equal. So it has to be on H because equidistant. Because A is a mirror of A prime. Yeah.
Oh, okay. So you
So
just
these are
join it
x.
up and then you reflect. Is that what you're saying?
Yeah.
Yeah, you join it up, you reflect, and you don't assume x is the intersection is on HK.
Mm-hmm.
Then the AX is equal to A prime x.
Yeah.
Or yeah. So then it has
So
to
there's no way that you
because
can't have
it's- yeah.
you can't have AX off of HK because that wouldn't make any sense.
Because that means B, the HK would not equal to B.
Yeah, I guess if you just joined it, right?
Yeah.
That'll get fixed when you reflect, and the A prime will go to A, right? And lines are preserved. Yeah. And that would reflect to this. And then because the angles are the same, that means this is collinear as well. Yeah. Another way of saying it. Okay, cool. The properties of vertical angles permit us to label angle AXH equals angle B prime XK.
Yeah.
Yeah, we just labeled that, right? Hence, angle AXH equals angle KXB.
Alpha equals beta.
Oh, so alpha equals beta, yeah?
Yep.
Because vertical opposite.
I don't know.
It follows that the shortest path from an arbitrary point A to the mirror.
Wait, it's not that A. Sorry.
Is it that?
You already wrote point A. Like what do you mean? Arbitrary?
Well, but I didn't define where it was, so it's still
Oh,
arbitrary. Yeah. To the mirror, and hence, thence, what the?
Then
What?
Maybe you can explain that.
Thence.
Thence. To a given point B on the same side of the mirror
It's probably then hence.
is the broken
Thus
line
hence.
AXB.
Thus hence.
Ah.
Say again?
It follows that the shortest path from arbitrary point A to the mirror and thence to a given point B on the same side of the mirror is the broken line AXB. Does that make sense?
Oh, okay. So like the shortest
Yeah.
path you can take.
So like, I guess
Shortest line from A and B
in
dash.
principle it could do something like this, right?
Yeah. And then bounce back up.
Yeah. But we're saying this will always be longer
Why?
Then what? Then which one?
than the red line. So any blue line is longer than the red line that goes from A to B.
Oh yeah, because if you reflect it, it's a straight line, so yeah.
Yeah.
Oh yeah.
Yeah.
It's
Yeah,
equal. Yeah. Okay.
Ba-
Oh okay. Yeah.
So any line is like
Oh.
bent.
So if you compare the distances, this is the kind of the punchline of this
Yeah.
chapter, this section. So if you reflect B to B prime, right?
Hey, we use
The,
this in
the
all
blue line,
dimensions.
the blue line's length will be preserved, yeah. Right? That makes sense.
Because congruent triangles.
Okay, so then the distance between A and A prime by this blue line is the same as to A to B with that blue line, right? And the same with the red line, yeah? So therefore, it's a triangle inequality, yeah? So the red line is the shortest line because it's a straight line, straight.
Because one side of it's fine.
Yeah. Yeah.
E.
Yeah. Yeah, that's pretty cool. Oh, for as we see, okay, they're explaining what we already saw. It's a good feeling.
It's a good feeling when people are explaining something.
For
you
as
already
we
know.
see in figure 4.4b, I guess that's figure 4.4b now. If any other point y were taken on the mirror, the path ay plus yb equals a prime y plus yb. So if any point y, then ay plus yb is equal to a prime y plus yb. Oh, they reflected the A instead.
Yeah.
Oh, this is explaining.
It just shows I didn't copy them because I reflected the B.
Oh, this is explaining. This is explaining
I can show you that I didn't copy it because I swapped out the variable.
I did a trivial change to the answer, so therefore it's original.
It's like when I follow math problems, I always use variables to say, oh no, I didn't.
So this would be longer than the straight segment A prime B. Yeah. Okay, so they did it like this then.
Okay. Because you're too dumb to even comprehend your
It starts using the longer variables.
This incidentally shows us how to solve geometrically a famous extremal problem without having recourse to calculus. I guess this is the when calculus came about, I guess everyone was calculus happy about everything. And sometimes it's more elegant. So physicists tell us that a ray of light traveling from a point A to a mirror and thence to another point B will do so along a path that minimizes the travel time.
Wait, what? Can you prove that?
No, that's the principle. I'm pretty sure it's the principle.
Oh, it's like physics principles outside our range.
Yeah, path of least resistance. In a homogeneous medium, this time is proportional to the distance traveled.
Wait, can we prove? Can we use this to prove refractions like in a liquid?
Maybe.
Why the angle changes? Because when both sides have the same like resistance, you have the same angle.
Yeah.
But if water is harder to get through than air, I'm pretty sure my math teacher actually did this with us.
He's a maths teacher.
Okay, so this time is proportional to the distance traveled. So a ray of light that goes from A to B via a mirror and meets at now angle alpha leaves it making an angle alpha. For this is the result of requiring a path of minimal length. Physicists customarily measure angles from the normal, a line perpendicular to the mirror, instead of the mirror itself. In figure 4.4c, angle I is called the angle of incidence and angle R is called the angle of reflection.
This is just turned into my science textbook.
Correct.
Alright. And I guess that's nice that it's short and sweet, and that's where it ends. Okay, maybe we can do an exercise to seal the deal, okay? So exercise 2 says, if the base and area of a triangle are fixed, okay, makes sense.
Yeah, so it's quite
The perimeter will be minimalized by isosceles-ness.
Okay.
Wait, isn't it
Yes.
minimized by equilateral?
Well, it can't. The base is fixed, so you don't have a choice. The base is fixed and the area is fixed,
Oh,
It's fixed.
so you don't have a choice for equilateral.
Because you can only move the height around.
Yeah. If the base is
Think of like that thing,
Yeah.
straight line.
I think it's
yeah. Well, let's do it.
height is the perimeter.
Yeah, that was probably the coolest thing about
Oh no, just
reflections.
reflect it above,
Yeah.
like the point on top there.
Yeah.
And then, yeah.
Oh, so the base is fixed. Should I draw fixed stuff in blue? And then this
The height is
is fixed, yeah. Okay.
to reflect it upon the dot of the line. And you get two straight lines. When it's isosceles.
Wait, say that again.
Reflect it upon
Reflected upon the blue line.
the blue dotted line.
Blue line like up, flip it up.
Flip it up.
Yeah.
So
Oh.
and you get two straight lines when it's isosceles.
See, I clearly didn't know the answer before this. I would have just drawn it on the bottom. So I reflect.
Still not.
It was once fixed,
Compensate.
but nothing is truly fixed. Alright. So this base is fixed, yeah?
Making a baby triangle.
So you're reflecting up here, yeah?
Yeah.
So the height will be the same.
And the perimeter is equal
Perimeter is equal to
So
two
that's-
straight lines.
That's twice of the perimeter.
Yeah.
At least when it's
Least
two
when
straight
it's
lines.
two straight lines, and and if you move it any other side, it becomes longer.
Yeah,
It's not too straight line.
Can we say this?
It's a straight line.
Because, like, you still have to prove that
Why
it's
because
So I guess there is an isosceles. So there's an isosceles triangle somewhere here, right?
Yes.
And how do we know that's straight? Perpendicular. Oh, okay, and that's congruent.
But it doesn't matter what the reflection will always be congruent.
no, but it's like vertically opposite because they're equal.
Oh, okay, and then we compare it to like another triangle
Or it's not isosceles.
that does something like this. Yeah. Yeah.
Yeah.
And if we were to reflect it, we'd get like
Which is two, not very straight.
like this. Yeah. Oh, this is cool. So,
That's a straight line, that's not a straight line.
how do we compare this?
Maybe draw one that has an altitude inside.
Well, we can compare. What do you mean, how can we compare it? Isn't it obvious?
Well, okay, yeah. So it's obvious that this red line, right,
Yes.
is shorter than this blue line plus this blue line. Yeah. And then this red line is shorter than this
Yeah.
red line. Okay.
And then
Now
the
it's so can you see like we're trying to just making it explicit, yeah? So that's not as important as people make it out to be, but the problem is people make it out to be so important. That's where like recognition comes from, if that makes sense. Yeah. So that makes it very explicit, right?
Yeah.
So the perimeter. This is just twice the perimeter, and the shortest distance is a straight line. That was pretty cool.
Isn't it obvious that 2 points are the shortest distance?
Yeah. That's like the triangle inequality. Yeah.
Can you also just say like the shortest distance between two points is a straight line?
I suppose, yeah. I think that's obvious enough. But the problem is like, why are we saying what's the significance of the shortest distance between this point and this point, right?
Yeah.
That only makes sense if you're actually using the blue lines to make that same trip, yeah. And then you make it shorter. It's the same the other way. Okay, so that was exercise 2, 4.4.2. Okay, we'll stop that there.